welcome to the session. In today's session, we will be describing about the basic performance characteristics of a computer system. We have already exposed you to the basic concept of von Neumann architecture. But all those terminology which we have told to you, that is the CPU, the memory and the input-output devices, are related to basic performance terminology. Our objective of this particular session is to introduce you to the individual performance terminology of various components of von Neumann architecture machine, and we will be substituting or we will be appending that particular information with some basic information about the performance of whole system. To begin with, what we would like to describe is what we mean by performance of a computer system. Well, the performance of a computer is defined as the ability to execute instruction in accordance to the specified configuration capabilities. Well, what you have to understand in this particular sense, that a computer system and its performance is recognized in completeness. It is not recognized as a component-wise performance. However, whenever we talk about the performance-based terminologies, we always define performance-based terminology for the components. Therefore, there is need for some specific standards or criteria by which we can define the standard performance of a particular computer system. We will be talking about those towards the end of this particular session, but to begin with, we would like to define the basic performance characteristics of any computer system. The basic performances of a computer system is measured for, that is for the processor, for the memory, for the bus, for the storage technology and I/O devices, and all about things are put together into one particular performance test, and that is the overall system performance. And that will be the major concern in any computer system, that is the overall performance of that particular system rather than the performance of individual components. Yet there are significance for individual performances in terms of when we want to compare two different technologies. For example, if we want to compare two different processor technologies or memory technologies, the performance characteristics of those devices has to be taken into consideration. So keeping that particular thing in mind, we would like to define individual components first, individual component performance first, and then we will be taking on the overall system performance. As far as the performance of the processor goes, the very first thing which we define is the number of bits which are associated with the processor. Many a time you hear the term like, this is a 32-bit processor, Pentium is a 64-bit processor, 486 is a 32-bit processor, P4 or P3, which will be coming in the P3 and P4, whatever the new processor terminology will be talking in terms of newer processors, we will be hearing 64, 128 and all those kinds of number of bits associated with the processor. After all, they are related with something into the computer, with the processor technology. And what is that? Basic 32-bit processor terminology is associated with two basic facts. The first one happens to be that it contains a 32-bit integer data which may be processed at one time. Now this is, once again I am reading it, 32-bit integer data which may be processed by the processor at a time. It is a very good systemic measure of a processor performance. The second one happens to be the size of address may be 32 bits. The significance of the size of address happens to be that it is associated with the memory addressing capabilities of a particular processor. For example, if the address size is, let's say, 10 bits, then a processor can access maximum of 1K of memory, which is 2 to the power 10. The similar example which I have shown you in the slide is if the 32-bit memory address capability is associated with the processor, then it can refer to, or it can address to, about 4 gigabyte of memory which is available to us. That means the overall memory capacity. The memory, we have to understand this particular memory in context of main memory. As far as in the von Neumann architecture is concerned, we define this overall memory to be the main memory, and the role played by this particular memory is that it stores the instructions as well as data, that is the program as well as data, before any execution can take place. So the significance is associated, can be associated with this particular thing. The higher is the memory, the larger can be your programs. Maybe when you will be knowing about the operating system concept, you will be coming to know about something like multi-programming. That is, multiple programs can be executed by a particular computer at the same time. Maybe not at the same time if it is a uniprocessor system, but it simulates that kind of a situation. Under those circumstances, what we need is more memory, as multiple processes or multiple programs are to be loaded into the memory, and that is why the bits of the processor is one of the most significant unit for any processor system. What are the other processor performance criteria and how they are related to the processor? Well, there are 3 basic performance criteria associated with the processor. They happen to be clock speed, MIPS, million instruction per second, and third one happens to be flops. Well, what is the significance attached to all these kinds of terminology? One of the terms which we have quite often for any processor happens to be the clock speed. You might have heard that Pentium 2 is 400 megahertz, Pentium 2 450 megahertz, Pentium 3 450 megahertz itself, 500, 550, and maybe when we will be getting P4, P5, P6, then we will be talking in terms of giga megahertz or gigahertz of that particular clock. After all, what this particular thing is? Well, the clock speed is related to, a clock is an internal device of a processor which regulates the rate of execution of instruction and synchronizes various computer components. Now, that is a very important information. In addition, clock speed is expressed as megahertz. That is what we would, these are the 2 things which we would like to define. The associativity of clock speed with the processor lies down in the basic fact that the role of the processor is to execute instruction. Whenever an instruction execution has to take place, there are going to be certain steps which are to be performed for instruction execution. They may be fetching the instruction, decoding the instruction, and ultimately performing the desired operation onto the data. Okay? So there may be several steps which are performed by the processor while execution of instruction, which may involve some sort of transfer from to the memory, that is the instruction as well as data will be transferred from the memory to the processor. But all the time we need something to synchronize the movement of data, to synchronize the internal processes of the processor, and that particular thing is achieved by the clock speed. So if this is the meaning of the clock speed, and if it is measured in terms of megahertz and so on and so forth, but what is a megahertz? Just 1 megahertz is equivalent to 1 million clock cycles per second. That means in 1 second it is emanating around 1 million clock pulses, under which, basically under the synchronization effect of those clock pulses, the instruction execution will take place. Now, if that is so, then definitely the instructions, number of instructions which are to be executed by the processor over the period of time are dependent onto the clock speed. But is that so? Well, that is what the next question which I have put for you. A faster clock speed, does it imply faster computer? And I have given two answers. Unfortunately or fortunately, both of them are correct. The case yes implies in those cases when we are talking about similar kind of processor technology. For example, if I am talking about P2, 400 megahertz, P2, 450 megahertz, the chances are that an instruction implementation, for example, an add instruction implementation or a multiply instruction implementation in the processor may be involving similar number of clock pulses or clock cycles. If that is so, the faster clock speed means faster processor, and that is why we normally prefer the faster or the faster clock speed processor whenever we are talking about that. Okay, will it give better performance? Which one will give better performance? Most probably the processor which is having higher clock speed. But this particular logic fails when we are talking about or we are trying to compare two dissimilar processors. In the case of two dissimilar processors, the chances are that the similar add instruction in one processor may be executed in 2 clock pulses. Onto the second processor, it may be taking 10 clock pulses. In the second processor case, the clock speed may be higher. It may be, let's say, 100 megahertz. Onto the first processor, the clock speed may be hardly, let's say, 50 megahertz. Even then, the addition instruction execution for the first processor will be faster. So you can make out that this is not the true measures of processor speed or processor performance, but it is definitely a rough measure which can be incorporated in cases whenever you are trying to compare two almost similar kind of processor technologies. One more thing which I would like to point out here is, fine, the instruction can be executed in some clock pulses, but is there any case where an instruction can be executed in 1 clock pulse? And how it is going to be possible? Well, there are cases when we can execute 1 instruction per clock cycle, and that is the technology we call RISC, that is Reduced Instruction Set Computers. What is the logic behind those technology happens to be that they involve a concept called pipelining. That is, all the steps which are required for execution of instruction are done with the help of a pipeline. What does it mean? Suppose the first instruction is doing instruction fetch, okay? Or let's say the first instruction is doing execution of the instruction. The second instruction might be fetching the operand. The third instruction might be in a position to be fetched itself. So that way we actually increase the overall throughput of the system, and we try to execute 1 instruction at a time. The second performance or second thing which I would like to point out here is, can there be a situation where we can have more than 1 instruction getting executed per cycle? Well, those instances are existing. Those kinds of processor technologies are already existing into the market, and we call them superscalar architectures. The objective of superscalar architecture is that it executes more than 1 instruction per clock cycle. How can it achieve it? Probably it will require more than 1 instruction execution cycles. In some sense, that sense, basically having more than 1 pipelining into that particular processor. So this particular thing is going to be possible only if we have multiple pipeline existence and each pipelining is working on some instructions simultaneously. Okay, so with this kind of technology we can achieve more than one instruction execution per cycle, per clock cycle to be more precise. And these technologies are getting more and more popular. However, our objective is not to go into major details of these technologies. These technologies, as you go into your second and third year, we will be explaining you in much more details. The other processor terminology which you will be hearing in the market happens to be MIPS, which we call million instructions per second. It happens to be an old measure of computer performance, and it basically measures the computer speed and power. What you will find, why this particular measure is not a very good measure, is that with different processors, number one, the requirement for a particular instruction or the time required may be different, or even in the same processor, what you are going to find, and different instructions may take different amount of time for execution. So how can you define a common measure for all those instructions? Well, that is what my third point in the slide says, or the fourth point in the slide says, that is no standard method for MIPS calculations. And that is why what I would like to define, this particular terminology, that is million instruction per second, this particular terminology has become an old terminology, yet it gives us brief or let's say broad indications that a given processor may be faster or slower than any other processor. In fact, in the next slide, I am trying to define what MIPS stand for. And one of the things which I have mentioned over there happens to be meaningless indicator of performance. The second point which I have mentioned is it just provides the general idea of CPU capability, which I have defined to you. And third point which I have said is Pentium-based system may run at 100 MIPS, which is just a rough measure. You may have 450 megahertz as the clock pulse, or 400 or 300 megahertz as the clock pulse, yet 100 MIPS as your instruction. So is MIPS meaningless? If there is no standard performance measures available for MIPS, then probably it is not a good measure, yet we cannot call it a totally meaningless measure of information for the measuring the speed of particular processor. The third and the final term which we are defining in this particular lecture happens to be flops. What does flops stand for? It is floating point operations per second, and it is basically the unit of measure for floating point units. What is a floating point unit? In many computers, such as supercomputer, where you require number crunching kind of problems, okay, the measure is megaflops, gigaflops, which is equivalent to as 1 million flops and 1 million megaflops respectively. But what this particular flops means, we have not answered that particular question. Flop basically is whenever you run on a particular machine certain number crunching problems, which are real number problems. For example, take seismic data. If the seismic data is to be recorded and some program is to run on it, it requires enormous data which is of the type of real type, and processor needs to operate on that data. Similarly, when you are getting data from, let's say, satellite, it is enormous data, you require something, okay, some processing on real numbers. Okay, there may be many such instances where we require this kind of processing. That is, we require number crunching problem solution, and that is possible when we have something called floating point arithmetic unit existing in that particular processor. Supercomputers have many such units, and that is why we say weather forecasting data is put into it, being processed, and so on and so forth. So flops is basically a measure for high oriented or high technological oriented devices which are such as supercomputers, and mainly they measure the performance related to real numbers. However, you will find that supercomputer is not a very simple device, that it can only operate on that kind of data. It also can do some general purpose computation also, which basically is beyond this particular discussion. Once again, we may be talking about those things in some later on sessions. However, what we would like to define is, are these all three measures are sufficient enough to define the performance of overall computer system, or we still have to go further, define some more criteria in between and define the performance of overall computer system. After all, one of the most important part in any computer system happens to be the processor to memory and vice versa. That is one part which is utilized most often. Why? Even in one instruction execution, as I was explaining you the steps, it is fetching the instruction, decoding the instruction, fetching the operand. So two memory cycles are definitely required. So this is one of the most important data transfer part in any computer system. Therefore, if you require better performance, probably this particular part as well as memory speed is to be looked into. So what we basically have to look into, first the memory speed, and then we will be looking into the performance of the bus. Okay, how do we define the performance of the main memory? Well, there are basically two indicative of that. The first one happens to be the access time, and the second one it happens to be the cycle time. But what are these times? After all, what is access time, what is cycle time, and how they are defined in the context of main memory? Well, access time is defined to be the time taken to perform a read or write operation by the processor from the random access memory or the main memory. Once again, I would like to define it further as it has been given in the slide. The time from the instant that an address is presented to the memory to the instant the data is stored or made available for use. So access time in that particular context is, you request a memory read or write operation. For that, what you need to do, you simply apply the address of the location which is to be read onto the bus, and what will happen, that particular, once the address has been applied, from that instant onwards, when the data is ultimately made available to you by the memory, that is called a cycle time. What is the significance of the cycle time? The main significance of the cycle time happens to be, we expect the cycle time to be almost as fast as the performance of a particular processor, probably almost equivalent to the clock speed of a particular processor. Okay, so cycle time is very much associated with this.